Good morning, Overall Middle School students. This is Mr. Woolley. And remember, the information contained in this video is intended to be viewed only by the students in Mr. Woolley's classroom. By watching the video, you agree that you will not record or share the video with anyone else who's not a student in Mr. Woolley's classroom. Alright, today, lesson 21. It doesn't take too long to go over this, and it's a concept that you guys already should understand by this point because we've already worked with some of our equations. We're talking about if-then moves. Like, if we do something, then this may happen. Alright, so here's our situation here. Remember, pretend that you drew three cards, a 2, a 1, and a 3. And 2 plus 1 is 3, 3 plus 3 is 6. So your score would be a 6. Now your partner, they don't have these on here for whatever reason, but we drew them here separate. Your partner has three cards also. They have a 2, and a 2, which of course totals 6. All right, so each of you both have the same score right now. So your event is to draw a -2. So if you had a 6 and they drew a -2, your score would now be 4. And then if your partner had a 6 from their cards and they drew a -2, it would still be a 4. So we're still tied. So if the previous sums are equal, then the same number added to each score will make the sums remain equal. So it's like working on both sides of an equation, how we have to make sure we do the same thing on both sides to keep it equal. All right, so our scores were a 4. Now, let's pretend we draw a +1. 4 plus 1 for your score now boosts you up to a 5. And then your partner, they had a 4 also. And then their score added 1, gets them up to a 5 also. So you get the idea. Whether you're drawing positive numbers or negative numbers, as long as you're doing the same thing on both sides of the equation, or in this case, both people's hands, then the scores will remain equal. All right. So over on the next page, if the original hand, we'll say maybe for you, maybe this is your partner again, whatever, 1 plus a -4 plus a 2. Well, what's the total? Well, 1 plus 2 is a 3, and 3 plus a -4 is a -1. And then over here, the other hand, a 5 plus a -6 is a -1, and then if you had a 0 in there, it doesn't do anything. So both hands are currently a -1. So if we chose to add 4 to each of those hands, see how you got the same 3 cards? Now you added 4. Well, -1 plus 4 takes you up to a 3. Same 3 cards here. You add 4, takes you to a 3. What if you had all those cards? Then you got a -1 or a -1. Well, now it takes you down to a 2. Same scenario here. You draw a -1 or subtract 1, takes you down to a 2. As long as you're doing the same thing to both sides, even though they may look different, you should still get the same score. What if we had to multiply both sides by 3? So you had the score of all 5 cards, which was a 2. Now you times that by 3. Well, 2 times 3 is a 6. This total of these 5 cards was also a 2. Multiply that score by 3, and you're up to a 6. And then what if you had to divide your totals by 2? Well, previously, all this added together, then multiplied by 3, had given you a 6. And we divide that by 2, it's a 3. And this whole combination of cards was previously at a 6, and you divide that by 2, and you get a 3 there also. So everything keeps staying the same as long as you're doing the same to both. So here, the original expression is 3 plus -5, which gives us a -2. Now an equivalent expression to that, where I want to get a -2 for an answer, I can maybe say -4 plus 2 is -2. So same scores there. What if you multiply both of these by -3? So take this original situation, 3 plus -5, and you multiply it by -3. Well, this added up to a -2 times -3 gives you +6. In this whole scenario, remember, it added up to a -2 times by -3, it's a +6. So remember, if these two were equivalent, because they were both -2, then as long as you multiply both of them by the same thing, that -3, it will keep them the same. All right, so we got just a little bit more to look at here. Now, this is in the problem set on page 116. What they have is 6 different problems, and then they're going to try to figure out which ones are going to match. All right, so a 2 plus a -3 plus a 7 gives you a 6. Well, half of 8, 1/2 times 8 is 4, and 4 plus 2 is also 6. So A and E are going to match. And then move over here to part B. If I had a negative 4 minus 1, that should give you a negative 5. And if I had negative 5 halves times 2, well, I'm going to treat it like negative 5 halves times 2 over 1. And a negative times a positive, of course, is negative. And I can cross cancel these 2's here. Divide them both by 2, get down to a 1 and a 1. And I get 5 over 1, which is just negative 5. So B and C end up matching. Over here, I have D, and I have negative 10 divided by 2. I'll divide before I add, if you remember your order of operations from last year. That gives me a negative 5. Negative 5 plus 3 gives me a negative 2. And right here, 3 plus negative 4 gives you negative 1. Negative 1 minus 1 is negative 2. So D and F do match up. And they said write an if-then statement if negative 3 is multiplied to the following equation. Well, if this is true right here, a negative 1 minus 3 is negative 4, then if I multiply each side by a negative 3, they will still remain equal to each other. That'll be a positive 12. All right, and the last one we're going to look at, simplify the expression. Well, if I have a whole bunch of adding and subtracting here, it all boils down to ends up being 17. Now, rewrite the equation if 5 is added to both expressions. All right, add 5. Well, all these we know total to 17. So if I add 5, this is our total of 17. Add 5, 17 plus 5, and 17 plus 5 is still going to be 22 on both sides. So if that whole big long adding and subtracting problem is 17, then if you add 5 to both sides, the sum will remain equal. All right, and there we go. So thank you for watching, and go ahead and try your practice in Schoology.